Hey everybody, welcome to a video on the difference quotient. Now, the difference quotient is one of those applications that you will see a lot in pre-calc, and then in calc it's sort of foundational for the definition of the derivative. You'll do it a lot with limits. Without getting into too much detail with it, our focus right now is being able to simplify it completely because it is essentially an application of composition of functions. So first thing to remember is when you see a function like f of x equals 5x minus 3, you want to really internalize the fact that it's f of input equals 5 input minus 3, right? X is just a placeholder for the input. 5x minus 3 is just describing the rule for the input, or the function itself. So let's check out what if we were doing f of m. We have f of m, right? We're thinking f of input is 5 input minus 3. So f of m, you know what? That's just 5m minus 3. So not too bad. It just substitutes where the x would have been. It starts to look funny, though, when we look at x plus delta x. Now, this may be the first time you're seeing delta x. All that really means is the change in x. And that's something that we'll come up a lot in calculus. But for now, we're going to think about it as its own sort of variable, right? Delta x and x cannot be combined. You can't factor out a delta. That makes no sense. Delta x is its own thing. So we're going to treat it like two different variables. And what we've got is 5 parentheses x plus delta x minus 3. So we get 5x plus 5 delta x minus 3 when we distribute it. And that's about all we can do. Again, delta x and x are two separate things. We're not going to combine them here. But what we've done is we've set ourselves up to be able to find the difference quotient. Now, think about the words difference and quotient, right? Difference is subtraction, right? You're finding the result of subtracting two things. And quotient is division, right? So this literally has subtraction and division in it. And without getting into too much detail, it's also related to slope, which is kind of cool if you want to start exploring it. But right now we're just focused on simplifying. So if you look at it, f of x plus delta x, we've done that first part already. That comes from that right there. So f of x plus delta x, we can write that in. 5x plus 5 delta x minus 3. And then we can do minus f of x, right? Which is 5x minus 3. That's just the original function, f of x, right? So we're going to write that in as minus 5x minus 3. All over delta x. Okay? Now, biggest mistake people forget to do is distributing this negative all the way, right? So we're going to write 5x plus 5 delta x minus 3 minus 5x plus 3. And what you will notice is some things that are going to combine to be 0. So 5x and negative 5x, that's 0. Negative 3 and 3, that's 0. And look at that, 5 delta x over delta x. Now, again, delta x is its own variable, or we're going to think about it as its own variable right now. And it's going to cancel out. So look at this whole thing, this whole difference quotient equals 5. Now, that's not always going to happen to be that nice. We're going to see an example where it's not quite that nice, but you should see things simplifying, right? Now, let's try another one. This time we got g of x equals x squared minus 4. Now we have a quadratic, still with two terms, right? But things are going to happen slightly differently with the quadratic. G of r, well, that's just a warm-up. That's r squared minus 4, right? No surprises there. Now, g of x plus h, most common thing people forget to do here, right, is square the entire thing, right? X plus h squared minus 4. Again, you can think of g of x as g of input is input squared minus 4, right? and the input this time is x plus h, for x plus g of x plus h. So let's do our instant FOIL, 2xh plus h squared minus 4, right? Because we're squaring x plus h. And I look at that and I'm like, you know what? Can't do much with it. Have to kind of leave it. But it has set us up for the difference quotient. So our difference quotient, again, we'll start with x plus h. Now, quick note, if you compare this to the last one, you can see that the h here is really acting as the delta x, right? You can see different things in place of delta x, but it still works the same way, right? It's a variable, it's a placeholder. We really can put anything there and have the same structure. So if we do g of x plus h, we get out x squared plus 2xh plus h squared minus 4. That's exactly from up here. And g of x itself was x squared minus 4. If you're into color coding and you want to do that, x squared minus 4. Again, don't forget parentheses. Now, one thing you could do right here, it's all over h. One thing you could do right here is say to yourself, you know what? If I distribute this negative and this negative, I'm going to get x squared and negative x squared, so that's going away. And a negative 4 minus a negative 4 will also go away, right? So what I'm just left with now is 2xh plus h squared over h. Now, one thing you can do here, right, is ask yourself, anything going to simplify? And the answer is yes. We can take out an h from here, right, and actually divide that h to 1 and simplify and get 2x plus h. If you had seen that h was common to everything here, every single term in the expression, you also could have taken out an h. You'd be left with a 1 in the denominator. But this is our fully simplified difference quotient. So it didn't simplify down to just one number, and we actually still have an h in there, but it did simplify kind of nicely there. All right? So here's your task. You've seen these two examples. What we're going to do here is try this out. So the first one is h of m plus 1. Try this as a warm-up just to make sure you're okay with composition and you're doing it correctly. Pause the video now. Okie dokie, how did you do? So let's see. My final was m squared plus 3. Did you remember to FOIL? Did you remember to distribute the negative? These things, super important. You want to do it correctly every time, right? And just get in the habits. So m squared plus 3 was a. Now let's build up to the difference quotient. Try x plus h of x plus delta x. Try that now. See how we do. All right, so checking over, and again, I'm going to put equal sign. Another good habit I should really be consistent with is as we go, I'm going to write that equal sign. And that's about all that we can do in that one, right? It's so tempting to combine the delta x and x terms, but unfortunately nothing really happens, right? Nothing really combines. So hopefully you got that. The order is not crucial, but you probably have that same order if you did it correctly. All right, so now try the difference quotient. Can you bring it all together? H of x plus delta x minus h of x over delta x. Let's see if you can do that and make sure you simplify completely. All right, let's see what we got. Now, similar to the second example we did above, hopefully you see that when you distribute that negative, you get some opposite terms going on, right? And that x squared, the negative 2x, and the 4 should should combine to be 0 with all the terms for h of x. Then you end up with 2x delta x plus delta x squared minus 2 delta x. It's a good, if you're someone that gets confused with the x's and delta x, it's a good idea to put something like delta x in parentheses when it's being squared. That's what you're left with as that middle term, so that's what I did right here. And hopefully we see that delta x actually is common to everything here, and when we divide it all out, you get 2x plus delta x minus 2 as your simplified difference quotient. All right. Okay, let's try one more. So we just did a quadratic trinomial, and here's another quadratic trinomial, right? This time we're still in terms of x plus delta x, but try A, just a good warm-up to make sure that you're doing your composition carefully, all right? Go ahead and try A right now. All right, how did we do? So other than I need to put my equal signs, right? We're making equivalent expressions all the way down. Hopefully you got 12m squared minus 2m minus 3 for that. Okay. Just remember you FOIL first, do the binomial squared first, then you multiply by 3 in this step, right? Make sure you don't multiply by 3 first and then square. That's not right according to order of operations. All right, so hopefully you got that okay. Let's try p of x plus delta x and see what happens here. Go ahead, pause the video and try that now. All right, here's my work for this. I'm going to put my equal signs all the way down. Okay. Double check, make sure you did it. Similar in structure to A, but you have your delta x's in there. Can't combine anything at the end. And let's see, can you build it all up together and see, can you do it? Go ahead, try it now. Pause the video, see if you can simplify it completely. All right, so let's see how you did. So I had my blue was taken down from part B, right? And I realized again that when I subtract p of x, I get 3 things that cancel, right? So I kind of distilled it down to what was left. It was the 6x delta x plus 3 delta x squared plus 5 delta x. Just like we did in part C, a delta x is in common everywhere. All right, you can take it out as GCF or just say to yourself, you know what, I can divide out a delta x from every single term, including the denominator, and you should get 6x plus 3 delta x plus 5. All right, hopefully you are getting the hang of it. Again, you get really good at this. It's going to pay off a lot when you get to pre-calc and then to calc. So hopefully you are feeling all right. Get some more practice with it, and we'll go from there. All right, see you later, everybody.